The screencast is going to walk you through some examples of parallel lines cut by a transversal. So these should be in the packet that you have in front of you, and you should be working through these examples to help you then complete the rest of the packet. So we're going to use the idea of the angle relationships that were discussed when two parallel lines are cut by a transversal, or when two parallel lines, two non-intersecting lines, are cut by a line to intersect them. So if you take a look at example 1, it says in the figure A is parallel to B. Remember that those two lines represent parallel. Find the measures of all the missing angles. So we're given one angle, and we're going to have to think through the idea of the different angle relationships that we've talked about so far to help us fill in the rest of these. So if we take a look, for example, we are given the angle 99. So if we think about the angle 99, opposite of angle 99, the 99-degree angle, is angle 2. Angle 2, because it's opposite of 99 degrees, that makes that relationship a vertical angle. So that tells me that angle 2 would be equal to 99 degrees. The next relationship that I'm going to take a look at is going to be angle 1. If I look at angle 1 is next to angle 99. Both of those lie on a straight line, or line A. Because they both lie on a straight line, that means that the sum of 99 plus the sum of angle 1 has to equal 180 degrees. So our equation would look like 99 plus angle 1 equals equals 180 degrees. And then I'm going to solve for angle 1 and find that angle 1 would be equal to 81 degrees. So the measure of angle 1 would be equal to 81 degrees. So I'm going to go ahead and fill that in because I know my measurements now. So angle 1 is equal to 81 degrees. Angle 2 is equal to 99 degrees. Because angle 1 and angle 3 are vertical angles, that means angle 3 is equal to 81 degrees because vertical angles are congruent or equivalent. Okay, so again, we're going to fill in that that's 81 degrees. And then I'm going to use what I know about alternate interior and alternate exterior angles. So because, or even corresponding angles, so there's a bunch of different angle relationships that you could use to fill in the rest of these. So basically we're going to think about, well, this 99-degree angle here corresponds with angle 4, meaning that they're equivalent. So the measure of angle 4 has to be 99 degrees. Because angle 4 and angle 5 make a straight or linear pair, that means that angle 5 has to match up with angle 1. So angle 5 would have to be 81 degrees. Again, vertical angles. So angle 5 and angle 7 are vertical angles. So that means angle 7 has to be the same measure as angle 5, which means that angle 7 has to be 81 degrees. And finally, angle 4, which is 99 degrees, is vertical to angle 6, meaning that angle 6 would be 99 degrees. So notice that in this example, we use the idea of vertical angles, and we use the relationship of a linear pair, and we use the relationship as well of something that we've talked about before, which would be our supplementary angles because they have a sum of 180 degrees. Example 2 is now looking at a little bit more of a complex example. So it says in the figure A, B, and C, so lines A, B, and C are parallel lines, and then line T is the transversal, so that's what's intersecting our parallel lines. So we're going to take a look. We need to figure out the value of x. So right now, what I'm going to do is I'm going to think about, well, here's 75. This angle 6 is corresponding to 75, so that's also going to be 75. And this angle 10 is also corresponding to 75 and angle 6, so that's also going to be 75 degrees. Because I know that angle 10 is 75 degrees, if I continue that straight line, this angle, angle 10, plus x plus 25 equals a sum of 180 degrees because it is a linear pair, meaning it makes a straight line or a straight angle. We could also look at the idea that the two angles are supplementary angles, meaning again that they equal 180 degrees. So we're going to go ahead and write our equation. So our equation would be x plus 25 plus 75 equals 180 degrees. We're going to combine what we can, so we get x plus 100 equals 180. We're going to subtract 100 on both sides, and we find that x is equal to 80. So the value of x would be 80 degrees. The value of this angle, so if we do 80 plus 25, would get us to 105 degrees. Example 3 is using the idea where we have 60 degrees here and we have 2x plus 10 here. Essentially, these angles are in the exact same spot, just on different lines. So these would be what we would call corresponding angles, and since they are corresponding angles, that means that they are equal to one another. So our equation for this would be 60 is equal to 2x plus 10. So we're going to draw our line and go ahead and solve our two-step equation. So we're going to subtract by 10 on both sides. 10's cancel. We're left with 50 equals 2x. Divide by 2, and x would be equal to 25 degrees. Because x is equal to 25 degrees, when I go ahead and substitute back in to my equation, I should get an answer of 60. So 2 times 25 is 50, plus 10 equals 60. So that tells me that I have the correct answer for x, where x would be equal to 25 degrees. Example number 5. Again, we're given two angles. These angles are going to be our same side interior angles because they're on the same side of the transversal. They're both on the right, and they're in between the parallel lines. If we remember what these mean that they are supplementary. Okay, so our same side interior angles are supplementary, meaning that they are equal to 180 degrees. So notice that I wrote down the relationship because I think that's going to help you again to make sure that you are recognizing what relationship is comparing or is relating the two angles together. So because these represent a supplementary relationship, that means that our equation is going to be equal to 180, and that means that when we add x plus 118 together, we would get the sum of 180. We're going to go ahead and solve. So pretty simple equation to solve this time around. So we're just going to subtract 118 from both sides, and we're going to get an answer of 62. So x is equal to 62 degrees. We can double check that by doing 62 plus 118, which would again get us to 180 degrees. Final example is, again, we're given two angle measures. We're given 110 degrees and we're given x. These are considered our same side exterior angles. Okay, so because they're on the outside of the parallel lines, they are exterior, but they are on the same side of the transversal on the right side. The same side exterior has the same relationship as the same side interior, where they are equal to 180 degrees because they make a supplementary angle. So we are going to then set our equation equal to 180, and we're going to have 110 plus x equals 180. We're going to go ahead and subtract by 110 on both sides, and we're going to find that x is equal to 70 degrees. Again, if we wanted to make sure that this was correct, we could add those 2 degrees together, 110 plus 70, and we should get 180 degrees. So hopefully this will help you with some of the examples that you're going to do next. Make sure that you're referring to the different angle relationships in your note packet and use that to help you.